Hi, everyone. So, welcome to the first tea party, which is the product collaboration from iExec and Oasis. So, let me give you a little bit of the agenda today. So, first, we're going to have a quick intro about Oasis and iExec. Then, we're going to have a panel about teas and blockchain. And in the end, we're going to have, of course, open bar and delicious food. So please welcome Martin from iExec.
Hello, everybody. It's a pleasure to meet you. It's a pleasure to be here. Thanks a lot, Oasis. So I'm gonna start the presentation, and So over the next 10 minutes, I will introduce iExec, share a bit about our vision, the role we are playing in the DCC Alliance, Decentralized Confidential Computing Alliance, and most importantly, the powerful tools that we are providing for builders, tools that leverage this amazing technology. So let's have a quick look on the iExec history. We started in 2017 with our white paper outlining our vision of decentralized computing. Oh my God. And then in 2019, we launched our marketplace for computing power and data. Then 2020, we added the blockchain layer with key feature with ownership, transparency, and other. Then 2023, we started working on our amazing developer tools. And voila, it's why I'm here today. We are providing flexible solution for protecting, managing, and monetizing data within the Web3 ecosystem. So let's talk a bit about privacy. Privacy isn't just a feature, and I think we all agree that privacy is a human fundamental right. But in Web3, it can often be misunderstood and overlooked because privacy is not only privacy token or Tornado Cash stuff. It's way more. It's way more, and it's why we join the DCC Alliance. There, DCC Alliance. What is it? It's more than 30 protocols. It brings together more than 30 protocols. The main actor of the privacy technology, such Oasis protocol and iExec. We have all the same goal. We are all working together, and we are using different technologies like FHE, ZKP, MPC, and TEE, and that's pretty amazing. We are not alone. So regarding iExec, our approach is a mix between the off-chain part for the confidential computing, it means protecting data in use, it's an hardware-based approach, and an on-chain part with the blockchain layer. So, in details, the off-chain part for the confidential computing, it's powered by Intel SGX chipset. With this amazing chipset, we are able to create what we call an enclave, and then builders are able to compute data in a total private and confidential way. And the amazing part, we added the on-chain part with our smart contract called POCO, Proof of Contribution. It's a kind of band leader that creates a synergy between the privacy of the confidential computing and the immutability, ownership, and transparency of the blockchain. And on top of that, we built amazing developer tools. It can sound quite complex when we are talking about decentralized confidential computing. You can be a little bit afraid, but what we've done on iExec, we abstract the complexity and we capture this power and we put it in our tools. And what an amazing tools. We've got Data Protector. It's an end-to-end encryption tools allowing builders to protect, manage, and monetize data within the Web3 ecosystem. We've got Web3 Mail. Web3 Mail, it's a way to send an email directly to an Ethereum address. So I would be able to, just with your Ethereum address, to send you an email without knowing or storing your email. It means no more scam. And the best part is you can even monetize your email. It means you will pay, I will pay you $10, and I will be then able to send you an email, for instance. And we've got Oracle Factory. It's a way to create Oracle in a minute based on API data. And that's amazing because we got a quite interesting ecosystem. Our ecosystem brings together different partners, foundation, builders, developers, and we are there and we are building tools for builder, but we are building them with builder. It's why we are focused on educate them, supporting them with sponsored hackathon, grant and bounties program. And talking about builders, I just discovered a few weeks ago a mysterious project powered by iExec technology. I don't know really what it is. It seems to be a privacy-preserving airdrop platform. And it's powered with the Intel SGX and iExec technology combined with the ring signature. The amazing thing is with Intel SGX, it ensures that the wallet receiving airdrop will be never revealed to the airdrop organizer. And then with the ring signature technology, it mixes the user signature with a group of decoy signature. It means that it's nearly impossible to detect finally who signs the transaction. And I heard a rumor about it. A rumor that there is a potential airdrop. I'm not sure. It's just a rumor. So the first step will be to scan this QR code and protect your mail on the Privacy Pass platform. The Privacy Pass platform is a place when you can protect and monetize your email and earn token just by subscribing newsletter. Interesting. And the second step, you just need to join the Hush drop campaign, and then let's see what happens. So I will let this slide a few seconds, and if you want to scan it, you can. And 3, 2, 1, no more airdrop. Yeah, you can come in simulator. I will give you the QR code. So it's all for me. Thanks for listening. If you've got any question about iExec technology, TEE, and how you could integrate this amazing technology in your project, because something I didn't say, you just need to run npm install to install a SDK, then using this technology. It's a kind of plug and play technology. So amazing. Thanks a lot again. And if you've got some question, I don't know if there is a Q&A time. I don't think. No. Yeah? Okay. Is there any question? I don't know. Yeah?
Thank you. So how will your encrypted email work? How do I register for the encrypted email?
So your question is how the email features work, right? It's easy. First, we will encrypt the email with a symmetric key. The encrypted data will be dropped on a decentralized storage. The symmetric key will be dropped on what we call an SMS, Secret Management System. It's a database running in this TEE, in this black box, in this enclave where everything remains totally private. Then we've got an application, confidential application running in this enclave too. So it means that when you are triggering this application in this black box, it will get the encrypted data, then the symmetric key, it will decrypt everything, process the data, and return the result, and then disappear. That's cool. The whole iExec team is just there if you need to talk. And next you will have Anthony, research and research department. Other question? Okay, cool. I think it's clear. Thank you very much again, and see you later.
And now for Oasis. So surprisingly, I was at the hackathon in Bulgaria a few weeks ago, and I was hacking on their platform. And now we're all at the same place at the same time, which is it's really interesting. I'm here today to talk about a voting platform that we've been working on. It's live on testnet at the moment. Of course, we've got all QR codes. If you want to go and browse that, check it out, then you can. Although beware, it's a proof of concept and it works better on desktops, but it'll give you some context, and I'll give you some context first. So at Oasis, we have Oasis Sapphire, which is a confidential EVM that allows for private smart contract execution. At a very high level, this is how it works. So it's Ethereum compatible. The contracts have encrypted storage. The runtime state is encrypted, so node operators can't see what's going on. It has cool data encryption, so you can have end-to-end encryption between the dApp and the smart contract. Curiously, this kind of gives you MEV protection for free. It also has a 6-second block time, so things move along fairly swiftly. And we have a delegated proof of stake architecture, so you get full finality as soon as the block is mined. And of course, just like iExec, behind the scenes, we're also using Intel SGX to protect everything and give us verifiability. And so, of course, Sapphire is part of the bigger Oasis ecosystem. At the consensus level, again, it's a delegated proof of stake chain, which allows for a modular compute layer. One of the modules is Sapphire, the confidential EVM, but the modules are tested and verified by the consensus. So with the example of Sapphire, it is a decentralized application where the foundation will release a new version. This is a signed Intel SGX binary. Then the consensus votes on-chain to accept or reject the upgrade, in addition to which nodes are allowed to run it. So this is like a verifiable, decentralized, trustless platform running inside trusted execution environments, where the node operators can't tamper with the software. So we get some really interesting guarantees there. We're still exploring this. We still use many nodes for resilience, for fault tolerance, and for quorum. And then, of course, with trust execution, you get confidentiality and privacy almost for free. But how does a confidential EVM, in the way that we're doing at Oasis, change how you think about smart contract development? Because everything's running inside the TE, the storage and the core is encrypted, and this makes privacy really, really easy. So you can just change your variables in Solidity to private. And unlike on Ethereum, on Sapphire, nobody will be able to access it unless you have a contract method that checks some access control, for example, and returns it. And because the contracts are just Solidity, you can call out to other contracts. You can do arbitrary calls. You can deploy new contracts. You can make proxies and smart wallets. And this means that we have the same type of composable contract ecosystem that can evolves on Ethereum and other EVM chains. But where some dApps might be public, others may focus on confidentiality. And this means we can reimagine and build on top of like the token and contract ecosystem, but with selective privacy in mind. And this does change how you start to solve problems. And versus zero knowledge and NPC, there's no delay with creating proofs or verifying circuits, and it runs as fast as you'd expect chains to run. So one of the special things, though, is now that contracts have their own secrets, we can be somewhat autonomous. So you can do surprising things, like instead of having a transaction relay or count abstraction and ERC4337, you could just have the contract, validate a request, and then the contract can sign its own transactions using its own EOA. So if you want to get rid of all the infrastructure, you can just give the signed transaction back to the user, they post it back to the blockchain, and the contract has just submitted its own transaction on chain. So yeah, we're using this for voting, so you can sponsor the gas for a poll. So whenever people want to vote, there's no need to have gas, no need to worry about where to get the tokens from, do bridging. And of course, there's no external infrastructure or servers apart from the RPC server, so it's fully decentralized. And as part of our R&D and innovation efforts, we've been exploring ways to make some difficult things easier, so specifically focusing on DAO voting and decision making. So a lot of DAOs have been operating on layer ones like Ethereum, and we've identified some critical challenges in the governance processes. So transaction costs have been a massive barrier to participation. We're talking about voting campaigns that can cost tens of thousands of dollars. And some people might decide, let's move it to layer 2, because that's an obvious solution, but then it creates problems. You know, do you bridge your tokens back and forth across the different layer 1 and layer 2s, and that has a cost in itself. Then dealing with things like unmovable staked tokens, how do we get those people to share their voice? And of course, managing vote delegation. So this leads to several key issues, like delegates struggle to truly represent their, constituents' wishes. The ERC20 votes token standard, you might not have built that into your DAO from the day one, but it also adds a significant per transaction overhead. Of course, like off-chain solutions like Snapshot make decisions non-binding. So most of concerning for me is a lot of DAOs pass with proposals that have like a 99% pass rate. So are we really making decisions, or is this just a rubber stamping exercise? What's fascinating for DAOs is they're still using the same sort of basic but intuitive knowledge processes that we have been for hundreds, maybe thousands of years. It's not necessarily a bad thing, but when translating that into something on-chain, it only captures the very last part of the process. So you see how that works in the diagram there. So someone does the thinking, and they craft a proposal, then the DAO votes on it. And that's pretty simple. But the problem is that all of these proposals are very high effort, and they're all or nothing. So you might put weeks or months into the process and the proposal, then it comes down to a simple yes or no vote. People might not read the full thing, and there's no middle ground, no nuance, and it can be quite disappointing at times. But what's worst is we only see the finished product, right? So all of the thinking, the iterations, the conversations that led to the proposal, they're all invisible. And that means that the DAO process can be quite exclusionary as well, where those decisions are only happening at conferences and telegrams and discords behind the scenes. And DAOs are locked into this, right? So even if you wanted to change how we get people's opinions, you'd have to submit a proposal to change the DAO, and it becomes really complicated and high friction. So in some senses, that means a lot of DAOs are decentralized and autonomous, but in name only. And yeah, that's exclusionary. But if you look at like the cloud of questions, instead of a big yes or no vote, we want to break these down into smaller manageable chunks. Like, what if we could spot the deal breakers really early before spending months on a proposal that's destined to fail? And delegates, likewise, you can ask those people, what do you think I should do? And they will, they can record their votes as in public for you. So all of these interconnected questions, this is what the inclusive voting looks like. It's about making the preferences public, sharing opinions, finding points of disagreement and agreement early, and bringing people into the process so you can temperature check, you can maybe ask them the spicy opinions, and get feedback from a really wide variety of people. So tokens that you wouldn't normally expect, you can ask, create a poll that's bound to that specific token. You say, what about all the people who have staked curve tokens? So not just governance tokens, but any token, any NFT. We want to target specific groups of people and ask them for their opinions. And this is where privacy comes in. So in the US, loads of people cast their votes in private booths for the presidential elections. And in the UK, we recently celebrated Guy Fawkes Night. So that's a celebration of an extreme case of disagreement with the government. But what's interesting is both of these highlight something fundamental about democracy, which is the power of private actions with public consequences. So, in the US, you vote in private, no one knows who you voted for, but everyone sees the results. And on Guy Fawkes Night, we celebrate the mask that became, a symbol of anonymous protest. So we recognize that in our most sort of critical decision-making processes, we have privacy built into this. But on-chain, you don't. And I feel this is really, really weird. So we're trying to address some of this problem at least. I mean, if we try an experiment of, if I asked your opinion about a controversial proposal, would you vote differently if everyone could see your vote? Or, if the tally is public, then would you vote differently if you disagree with 99% of the people who've already voted? Or if you voted for, yeah, what if your vote was kept hidden forever and we don't know if you voted or not? Would that change it, right? So privacy is not about hiding, it's about having freedom to express your true opinion without fear or pressure. And sometimes that makes a really big difference when it comes to making good decisions. So of course, we made the tool. Oops. We made the tool, I'm running behind the slides here. We made the tool to customize everything. So you can fine tune exactly who gets to vote, exactly how their votes get weighted. So you might reduce whale influence by taking a logarithm of the token holding, or even give everybody one vote. And likewise, we can control who can vote. So which NFT, which token, you verifiably prove that you hold those tokens on another chain, and use that to gauge who can token. But also with the privacy options, so we have complete control over the different privacy options. You can have a hidden poll that will only be linkable. You can share links to that and see how that propagates, or it can be a public poll that anybody can vote on. For sensitive topics, you might want complete privacy, or for public declarations, you can decide, I want to show the full voter list with what they voted for, but not show the tally as it's in progress. So, of course, this is open source. It's under the Apache 2 license. You can deploy your own smart contracts for access control. You can customize the privacy options. You can set the time limits. Some of these are pluggable options. Some of those are baked into the contract, but it's all open source, free to fork, do whatever you want with it. We do cross-chain snapshots using the ETH get proof method. So this is verifying a Merkle tree proof through the block header, through to the account, through the state root of the account. And that means we can prove a specific value for an address in the mapping, for example, the token balances in ERC20 token. Of course, not all of the RPC providers support this. So Infura, thank you very much, you support it, but not for Binance Smart Chain. Alchemy and others don't. So if you're trying to do decentralized applications, there are some problems there. You're reliant on full nodes on RPC servers still, but yeah, we're trying to do this as trustlessly as possible. So yeah, thank you very much. We're also sponsoring ETH Global this year, and it starts tomorrow. So if you're doing that, even if you're not building on Oasis, we're still discovering interesting things you can do with privacy and the Ethereum ecosystem. So thanks, guys. And any questions?
So you mentioned earlier that engagement is one of the key things that you're trying to solve, but I'm curious how you'll ensure strong engagement through the polling system, because as we've seen in other recent elections, that sometimes engagement in the polling and the results that we get from the polls don't always translate to actual results.
That's a really good question. I was kind of hoping that we would not just focus on DAOs and boring stuff. So if we get people engaged with more interesting questions on a day-to-day basis, then this becomes a habitual thing. So maybe every day like Reddit, I'll go and post my opinion on what I feel about stuff. And maybe we can incentivize this. Some tokenomics could go on there. But yeah, we've built the tech. We're looking for market fit and how to engage with people. And that's a good question. But at the moment, I'm not sure,
Hey, thanks for the presentation. So you spoke about the confidential EVM. I wanted you to have a bit more color in regards to what goes in and out of the key value database and and about the peer-to-peer traffic. So what goes in? All right, thank you.
So very briefly, I might zip back to, we have a diagram here. So we have the Sapphire confidential EVM that runs inside the trusted enclave. We have the key value database, which is outside of the enclave because you can't do storage inside that. So the node operator can see the enclave is doing reads and writes from the key value database, but the keys are encrypted and the values are encrypted. So that means we have the key manager here. The key manager on the side verifies that Sapphire Node is running the latest version according to consensus, that it's running on a node that consensus approves on it, and then it allows the smart contract runtime to have the specific keys that it needs to decrypt just that information. So of course, if you don't upgrade to the latest version, you're cut out of the committee that's allowed to operate smart contracts, that's allowed to decrypt data. So does that answer your question? The peer-to-peer layer. So we have transaction encryption. So again, in the enclave, it has a call data encryption public key. So when you want to submit an encrypted transaction, you negotiate a derived shared secret between yourself and the enclave, which gives you essentially end-to-end encryption between the dApp and the browser and the smart contracts on-chain. So that only encrypts the call data. So the gas, the from, the to, other basic meta information that we need to manage the mempool, that's public. But you can use multi-pool, you can use various proxies, relays to disconnect the gas pair from the actor. So anyway, thank you very much, guys, and thank you for the questions.
Hi. Thank you, Diana. So now it's time for the panel. So please welcome Matej, Head of Partnerships at Oasis. Also, we have Anthony, Head of Research at iExec. Then we have David, Engineering Tech Lead at Poetic Technologies. David, it's coming. Yeah. We have Marvin from FADA. Marvin, oh, he's coming. And our moderator is Marco from Oasis. Marco? Oh, sorry.
I came too early, sorry. Hello, welcome everybody. We have an amazing TE expert panel, a very homogeneous setup, which is surprising. Normally you have some opposing sides, so let's see how deep we can go. We just have one microphone, so I'll ask you to be kind enough to share. And let's start with some intros, I guess, but rather quickly. I think we only have half an hour, so let's get to the fun stuff.
Yeah, thanks, Marco. So I'm Matej, Head of Partnerships here at Oasis. Yeah, not much to add. I've been with the team more than 2 years now. A privacy maxi in private life as well. Not maybe to the extent of like a cyberpunk, but I do like my data to be safe, secure, and I see a lot of potential in this space also in crypto. So yeah, working on this to bring it to the mainstream.
Hi everyone, I'm Anthony. I'm the Head of Research at iExec. I've been at iExec for 5 years already, and Martin earlier talked about what we do with TEs, but actually we don't communicate a lot about it, but we also do a bunch of cool cryptography on top of TEs, and I hope I will get a chance to say a little bit more about this.
Hey, I'm MD. I work with a company called Poetic Technologies. We specialize in software supply chain security at the moment, and primary goal is to secure the software provisioning with infrastructures that will allow you to create a link between source code and binary, which doesn't no one practically provides at the moment. But apart from that, we also do application development in towards mutual credit and credit clearing. This also which is relies on using some non-conventional cryptography within TEs to provide more confidentiality guarantees in case a TE is actually broken, which is most of the time the case.
Hi everyone. I'm Marvin Tung. I'm the co-founder and CEO of Fala Network. This is my 5th year working in Fala, and we are founded in 2019. But everyone here is OG, so I won't say shit. Our goal is since day zero is to reduce the cost of the trust for Web3. We pick up TE because I'm a believer of T16Z. It's short for TE, MPC, ZKP, FHE guys. So we believe that only using a hybrid infrastructure that implement all of these cryptographic and security solutions, so that we can have a user-friendly, low-cost, save time, trustless solution for massive adoption into Web2. So this is what we do.
Thank you, guys. And let's start with some groundwork. Matej, I know you have children. Explain us TEs like M5. And then Marvin, maybe you can give us the pro version for how do you explain TEs to cryptographers.
Oh crap! I never explained it to a kid yet. So let's see. TEs are basically like special magic boxes, where you put stuff in, and then some magic happens in there that you only know about, and then that special result comes out, or that magic result comes out, right? And you can have verifiability that everything done in there was as it should be, but at the same time, right? You don't know what actually happened. I don't know if that's closest to what explaining it to like the child, right? But I would say for me, TEs are like secure enclaves where basically this is kind of or the BD understanding maybe more, but where you have secure compute that can happen without anybody else, not your provider, having access to that data, but at the same time you have verifiability of TF stations, other stations that things have the integrity, the results have the integrity, right? But at the same time they're secure. It's something along those lines. Maybe anybody else can try.
That was great. I couldn't do better.
All right, I will try to do it. So first of all, I want to evolve the concept of Web3 to the kids. There's a magic called Web3 that if you speak out loud some spells, then you can demand some robots working for you or elves, whatever. And it can work for you based on your spell only. So when you're speaking out the spell, you have to tell everyone this spell. So then the kid could ask, what if I don't want other knows I'm making the spell? There's a magic black box sitting here, and you can speak to the spell into the box, and the box will just drive the robots or the elves working for you without you telling everyone the spell. So this is how I explain the shit.
Okay, thank you.
The technical version.
That was the technical version, yeah. Let's get into actual TEs. There's a couple out there. In crypto, generally, Intel SGX is used. How come, and what else is on the horizon? Will we be stuck with SGX, or is there something new?
Well, SGX we've been out for a while, and the reality is SGX is not built for confidential computation. It's built for DRM. Was built for you not to download Netflix videos, and this is the reason why it has been broken many times. The new technology by Intel is TDX, Trusted Domain Extension, which is basically the same thing in many ways. It's like uses SGX under the hood. It has a bunch of intellectual property built into it, and the extension on SGX is basically having the full. Okay, so the practically reason the difference between SGX and TDX is the approach on which how you deploy and create the trusted domain. In TDX, it's virtual machine based, whereas SGX, like you have just a extension set, instruction set extensions, and GX provides much better ways to easier way to deploy and create a trusted domain. It has some improvements. We waiting for it to be broken, but the hardware principles we don't know, how they actually provide security in hardware, we don't know. And so the only I see the only real way to be dependent on hardware in future is having radically open designs, and this is something that we only starting to work on.
Okay. Thank you. Yeah, I just want to say a few words because so there is SGX, there's AMD CV, now AMD SCV SND, which is close to TDX. Another thing I've been monitoring for years and that hasn't really budged is ARM Trust Zone and CCA. So ARM Trust Zone is the original version of confidential computing, and like you said, it was only done for DRM. And there has been in the ARM v9 specification something called confidential computing architecture that has not been implemented on a chip yet. So it is in the specifications. ARM people were at the PET Summit this year in New York City. So PET Summit is the Privacy Enhancing Technology Summit. And they said, we don't have the chips yet, but we have the simulators, we have the SDKs, and there's everything that you need to actually start building applications using ARM confidential computing. And it got my hopes high. I was disappointed again because there was nothing. And then 2 weeks ago, I did my monthly search, and I saw that there is a new chip. So there is a vendor that is making cores that implements CCA for the first time. It's the first cores ever to implement the ARM CCA specification. Then there's an architecture that includes this core, and so very soon we will have chips that implement ARM CCA. So hopefully, if we meet again in a few months, we can say, "Hey, I've got this prototype running on ARM," and it's happening. Now the bad news is I really hope it will be for smartphones and laptops, and apparently it's more for ARM servers. But still, it's happening.
Anyone want to explain Nitro enclaves? Another option out there?
The only chips I want to add our comment is NVIDIA, right? Like NVIDIA also have confidential compute, and we are kind of using that for some AI use cases. But there's some, if you're interested to learn about what would happen if you want to put the Llama 3 level model inside the GPU TEEs, we have some benchmark. But the point is, it's not perfect. So, for example, because the NVLink connection is not ready for TE environment on this GPU, so you can't train large language models inside among multi clusters. But NVIDIA say that they will have NVLink pretty ready for this in maybe next year. So yeah, just add up this. Nitro is not real team, right? So.
But they provide remote attestations that you can actually verify even on our chain. But let's get to TEML in a second. Matej, as head of partnerships, I assume you often get pushback when explaining TEs. So what's the most common critiques out there?
Yeah, it's actually about, I think in Playtech Technologies, we're saying, that you need to kind of trust the hardware, right? That there's that trust assumption, right? But from our point of view, right, our director of the foundation, the Oasis Foundation, and the main developer as well, he oftentimes says, some say math is better, right? But hardware plus math, it's even better, right? So why isolate just to, I mean, just why use only TEs, right? You can add on top ZK, you can add on top FHE, whatever you want, right? And you can have different levels, of security based on the needs, right? If you just want to have private orders, you really don't care after execution if those become public, right? But it's very handy if they're private before hitting, the next, because nobody can then front run you, right? So I would say combining these technologies will be probably, at least from our perspective, more of an end game than just trying to, because ZK, FHE, there's a lot more overhead when it comes to deployment, when it comes to run the stuff, right? But with TEs, it's just it's very simple. You provision that, and you're running the same code as you would for anything else, at least in our case. So this is kind of the pitch from our side.
You alluded to our critique of like GE space, but I want to maybe a little bit correct that we kind of have no way not to trust hardware. Like we don't produce hardware, so like there's not a question. Like you like just you're in a situation like that you have been like and like if you use computers, you're already screwed. But the idea that we are focusing on is that there's many layers on top that are like low-hanging fruit for a lot of improvement. In our case, and what we are focusing on is that you cannot even trust the software itself because you don't run source code, you run binaries. And where did you get binaries? Like you don't really know. Someone did it. And like the very simple way to explain it, like who here has downloaded like uses Signal? Yeah, maybe a big bunch of people. Like, and how does the group in here probably have downloaded Signal from like Apple website, like Marketplace, and how from Google Marketplace? So yes, like end-to-end encrypted. You have like a channel communication between two parties that no one can eavesdrop, but you have a spy on both sides. So because there is a control structure that controls the distribution of binaries. It's very centralized. And so the supply chain attacks actually could have catastrophic consequences for blockchain space. And so our main critique is that like no one actually takes care of it. So what we do is that we trying to make a supply chain that is secure, that you can, when you run the binary, you actually know what you're running. And this is the YT communities, like the perfect adopter of that technology is that we really need to reproducibly build binaries and test it. Because in the case of TEs, the thing you're running in a TE is a public contract. This is like you have the encryption and you have attestation. These two things combined make the thing confidential because and if you have no real way to like reassure the people that this hash is a public contract you can actually trust, like there's no way to say that this is actually secure.
Yeah, totally agree. First of all, I do think like it's not like the best technology or the most security technology always wins. The world is not running like this, right? Sometimes it's a combination of different parameters. I believe in last Sunday, Georgia's the CTO Paradigm gave a very good speech on a Flashbot Hacker House, which is about 5-level TEs. So when we are consider about how the TE technology can adopt, there are some parameters he implement into the metrics. For example, security level, enabled use case, available use cases, developer experience or developer friendly. And in the beginning, we only have Intel SGX, right? And you have to hard code inside SGX. There are bridge use case or other use cases using SGX, but basically you have to rewrite the program 100%. And the next level is like SGX with square mean, right? You can kind of partially treat it like a VM, but you can't real. And the security is basically on the same level of Intel SGX, but with maybe 20% of trade-off in performance. And I think now we're basically level 3 and level 4, which means we got options. We got AMD, we got Trust Zone ready to go, and we got NVIDIA GPUs. We have Intel TDX, which in AMD SCV and Intel TDS, basically you can treat it like just a Docker, right? Like so, the developer experience could be really good, and you don't need to rewrite a program. You just like Web 2 in, Web 3 out. But still, the security checks for the hardware concerns still there. And when we're pushing it to the next level, let's say in the next level, somewhere in the seed, we can abstract the TEE into software level and providing, for example, open source TEE hardware manufacturing, which Fabric and Sylvan, they're talking about. But that could be a 10 years or 5 years. So I would say the level 5 is five years roadmap, and now we are pretty much between level 3 and level 4. So this is why exactly this year everybody is talking about TEE. You know what? Like in 2 years ago, 1 year ago, when we were hosting this kind of event, we don't even dare to say, hey guys, we are working on TEE. We use another term like confidential compute to replace the word TEE, because like crypto space, everyone hated it. But now people change their mind because we are reaching to the next level. Yeah.
Because cryptography had failures.
I was gonna say, I was yesterday at an AI event, and every single panel talked about trusted execution. TEEs are still considered low security guarantees compared to ZKML or MPC solutions. Anthony, do you agree?
No. No, I see where this is coming from. The thing is, cryptography approaches are very, very safe, pretty unbreakable, but also, I'm just looking at the room, they don't really work yet. And the theoretical background says that they're not going to work for a few more, I don't want to say decades, but years. So the thing is, when you're in this kind of event, when we talk about TEEs and things running in TEEs, inside TEEs, we are talking about real applications, things that you developed with your normal SDK, your normal language, and that we poured into a TEE. It's not that easy, but for a lot of applications, it works, and TDX, AMD, SCV are really changing the games. It is going to be super, super easy already next year. With FSG, ZK-Proof, MPC in itself, you cannot do much. When you go talk to these projects, they tell you, yeah, you can do anything. It's mostly, additions, subtractions, divisions are a little hard, but if you don't have too many of them, you can do divisions. And the size of your circuits, the size of your proofs, the size of everything explodes for real applications in cryptography. TEEs, on the other hand, are very powerful, very fast, but again, there are hardware attacks, sectional attacks. There might be vulnerabilities, there might be backdoors, who knows? And the thing is, at every iteration of TEEs, so there was SGX version 1, then version 2, now there's TDX. At every iteration, Intel and the others are relaxing some security properties. So I don't want to get too technical, but for example, in SGX version 1, you had memory integrity protection. In SGX 2, you don't have it. That means that someone who has root access on your server might write the memory, and your application cannot detect it right away. It's okay because it's encrypted, but you can still do a little bit of Nazi stuff. So it is fair to say that in some sense, cryptography like ZK-Proof are stronger, but also you cannot use them, and TEEs are actually usable, and there is a small scope of exploit that you can run. And obviously, the next logical thing to say is that we need to combine those, and I think everyone has realized that. So my first idea when I saw that was, you know what, it's easier. If the memory of my enclave might leak at some point, what I'm going to do is I'm just going to split it, and I'm going to put it on different enclaves, different locations. A zero-day exploit on SGX must be very, very expensive. It's also, if you look at these attacks that have been documented, they're very hard to execute. The idea is if you split your confidential data in 3, 4 8 parts and you put these bits in different locations, you will have to coordinate an attack in 5 servers in different places at the same time, and this is nearly impossible. And the next one, the concept is, yeah, but what if? Okay, we can split this data, put a little bit on TDX, a little bit on AMD, a little bit on ARM, and now you have to find 3 or 4 zero-day exploits and coordinate an attack, and now it seems more impossible. So I think the future is bright, but I cannot agree or disagree with them. Thanks.
Yeah, sorry for taking your time. Yeah, just want to share some secret here, okay? We are a TE party, so we can share secrets with a state share. So a few ZK projects, they are using TE. Most of the ZK TLS are not real ZK. Half of the MPC networks, which include the bridge solutions, are using TE. Most of the FHE solutions are using TE. So it's just like people using it, but won't dare to say that they're using it. Maybe in the documentary you can find it. If you check the configuration to run their node, you can find it. But they won't say like print it in their pitch deck. They won't put it on your website. But like TE already kind of adopting the technology market in Web3. It's just it's time to get out of the closet, guys.
Thank you. I would not have been as strict as you guys, but I'm glad we went there. Especially for the AI use cases, for any ML compute, anything that's rather complex, more than just one transaction to another address. TEs are the only option currently. That's why everyone's talking about TEML, but we still do not have it. You were hinting at single GPU attestations or enclaves. They do work, but obviously are a bit limited in use cases. So what's currently missing until we get to proper TEML?
So with ransomware experiments, because I don't work for Intel, by the way, they say that TDX includes some optimization specifically for machine learning, and that it is so much faster. We have run some tests with inference, not training, and it is indeed pretty fast. One advantage of TDX also, again, I don't work for Intel, but they include some acceleration features specifically for machine learning. So in theory, you can do some machine learning, and at the PET Summit, they even had a slide that was very nicely done. They said training for whatever under 10 billion parameters you can do on TDX. For more than that, you have to use GPU. So there are things we can do. I don't really understand this thing about GPUs because we've been looking a lot into them, and basically we've been playing with GPUs since April, I think, on Azure. And at the time there was no remote attestation. I think it's in alpha release. I think it's in private release right now, and it's the same for. So that was for AMD, and now there's an alpha release on Google Cloud from Intel, and these are joint attestations between TDX and H100. So I don't think anyone has them because you really have to be in a preview program, and so that's what we are doing. But we are not even in the preview program for TDX and H100. I also don't really understand how you can consider that this is confidential computing if you don't have remote attestation. Sorry. Oh yeah. Because in our use case, there is no use case for exec where you can execute something on a GPU without remote attestation. You have to prove to your users and to the protocol that something was running on a genuine enclave that is up to date. And with GPUs, it's even harder because you have to attest the CPU and the GPU, and you have to attest them together so that they can communicate. So yeah, I don't know. I see a lot of projects saying that they've been doing GPUs, and we have, but it's not going to production until we actually have remote attestation because it's just not secure.
You go.
I actually want to give the mic to Marco because he's our AI guy, so maybe he can share a little bit with us.
I'll give it to you, Marvin, in a second. But that's the magic, right? TDX can suddenly create this secure connection to a GPU. And NVIDIA does have remote attestations. As very recently, it was only single GPU attestations, but as far as I get it, finally we can do remote attestations with multi-GPU setups, and that's what for me is TEML, because you can.
Is it only GPU or CPU plus GPU?
CPU plus GPU, exactly.
Yeah, happy to share that. How TML work. So in the current, I can only speak for the current practical practice already kind of published. So basically, what you can do is connect TDX with NVIDIA H100. Let's say NVIDIA have its own attestation system. So what we did is that we insert a PyTorch inside the TDX to insert NVIDIA GPU driver, and we use the TDX attestation to attest the attestation from NVIDIA. So this is how the whole system works. The performance actually perfect. It's only 7% of the trade-off, and if the larger model you implement, the smaller trade-off you get. But as I mentioned, right, it's just for inference now. There's a bottleneck. The bottleneck is I/O between the GPUs. B, we don't have anything, so the training use cases is still on the way to go. Yeah, but I think TEML, but for inference is so ready to there. Yeah, we love to provide a testing environment and access to everyone here to give it a try and make your own practice. Very happy to. Just a funny.
One thing, something that people don't also realize, you can do inference on CPU only, and a lot of stuff do work. For example, I tried last week, image generation on CPU with TDX just works. Okay, it takes like 2 minutes, but it works.
TDX is great. I think we're out of time, but let's definitely do a couple of questions, maybe go more on the use case side of things, because that's what most people are here for. Questions?
Besides AI? Hey guys, I work with Vala, with Marvin, but a general question, if no one wants to ask a question. What other use cases, maybe Poetic wants to comment on this, besides AI, are you focusing on where T or TDX is actually used for as of today and in future?
Nice, something tangible.
Yeah, so I can start. So for us, yeah, TEs are used for secure compute on Sapphire, right? So that's one use case. We're also working on what we call RAWFL, runtime off-chain logic, where it has multiple use cases beyond AI, right? You can have trusted oracles that you can run, with these bridges and the like. So I would say AI may be the hottest word right now, so it's definitely good to be in the space. We also, added support for TDX now with RAWFL, and we're going to be looking at adding H100 soon as well. So that's definitely one use case where there's going to be a lot of demand. Pairing that with decentralized GPU market and making it simple for any data scientists basically to, just have their Python code ready and deploy it without having to be like a DevOps guy to set up everything for themselves, right? So that's kind of our vision. We're working close with Ocean, that's also in the data AI space, and we see kind of together where the demand is going. But as I said, multiple additional use cases where TEs can be a very kind of low barrier, quick deploy type of technology compared to other secure methods.
There are so many. I think one class of application that's just very obvious is anything related to data aggregation. It can be very small pieces of data, but if you need to put them in common somewhere to compute some things, I don't know. For example, you have insurance A, insurance B, insurance C, and you want to compute something over, everyone who wears glasses. You have to use a T because no one wants to share the data unless they know what's going on, and there's a sort of rule about who gets the results. And the nice thing is it's not only medical application. It's just banking, trading. At some point, I get the use case question. Right? There are so many. Like, what doesn't require privacy or confidentiality is the question, I think.
Why wouldn't you use it, right?
Yeah. Like, that's the thing. Like, if it exists, why wouldn't you use it? The only reason we're not using it is because it didn't exist and it was not possible. But if I told you that it's been available for 15 years, you'd be like, what the F has been Facebook doing? What the fuck is Instagram doing? So yeah, everywhere.
No, thank you, but that's a fair point. But and I believe so too, right? Is privacy when privacy verifiability is accessible? Why not? But I just moderated a panel yesterday on agents in DeFi, and I asked the same question: how much is verifiability and privacy important to your end users? And they say not that much. The agents should make money for the end user in DeFi. So it's also the because we sell a privacy solution, verifiable solution to the application stack, right? We are infrastructure with TEEs, and these end user applications need to be aware if they want to implement it in their roadmap, right? Especially in Web3, like the roadmap is very busy. So I completely agree with your point, but and this is I think what the infrastructure levels sometimes struggle with, how fast can we sell our privacy and verifiable solution? So, but I would like to hear other opinions.
Thanks for the co-hosting.
We're talking about use cases, right? Okay, so I mean, I'm not really personally we're not married to particular technology. Like TEEs for us is just like a tool. That's why we also use ZK within TEEs to increase the confidentiality guarantees to the level that we're okay with. And what we think in confidential computation rights is a tool to be able to have tactical advantage in current surveilled state, to organize in a way that you can not don't ask anyone for your without asking anyone. And it's intelligence equals power. And if we want to have any meaningful societal change and go away from the situation we're in, the society, and we have a lot of problems, privacy is one of the key tactical and strategical things we should optimize for.
I know the time is up, so I'll be quick. I'm a master of use case in Web3, TE use cases in Web3. So anyone interested, come talk with me. So actually, in Ethereum layer 1, the biggest use case for TE is MEV, censorship resistance. So most of the MEV work overflow is producing by single server called MEV relay for now. And if we want to, it could be so easy to add up censorship, filter inside it. So it's very dangerous. As Vitaly just mentioned yesterday, anti-censorship resistance is the next big thing of Ethereum. And it's about using TE to decentralize the MEV relay. That's a big use case for TE besides AI. Secondly, Uniswap, Unichain just launched the Unichain solution in a couple of days ago, and it's using TE for the pre-confirmation. They call it L2 boost. So it's a flash block with 0.25 seconds for the pre-confirmation blocks. So I assume in the near future, most of the L2s will have that component as default because they are competing with each other. It means that TE adoption will grow into an L2 very soon. So, and I also know, for example, Click team is using TE to for teams to airdrop claiming as a use case. And a lot of MPC and ZKTLS and FHE projects are using TE, working as defense in depth. So yeah, these are the use cases.
Thank you. And since no one is kicking us off the stage, I do want to pick up on this, since That's the fascinating part about TE is you get both verifiability, which is super crucial in the agent use cases. Whenever I have an agent do anything for me, I want to make sure that it actually does what it was programmed to and that I can verify that it used my input, that the output is verifiable. And then you actually have privacy, where you can do private prompting, etc., for LLM chats, etc., which simply doesn't exist currently. Again, no one is kicking us off. I don't mind one more question.
No, I'll do a call to action, right? So as you said, there's no reason not to use it. So if you want to be ahead of the curve, I guess, based on the prediction from Fala, then yeah, look how to use these in your projects, right? Connect with us. Oh, we have time. Yeah, chat with us, and let's see how we can get you ahead of the curve.
Sorry. Thank you. Give it up. Hey, there's a meeting. It's not right there.